permutations formula, which you will very rarely use, but it is on your formula sheet. Permutations formula says the number of permutations of n distinct objects taken r at a time is npr, which is n factorial over n minus r factorial. Okay? With that in mind, we will do question number 2 without it. And then we'll look at what it means to use the formula as well. If there are 8 students competing in a 200-meter race, how many ways can they finish first, second, and third? Well, you would have how many spaces? 3 decisions to make. We have to decide who comes in first, who comes in second, and who comes in third. I guess we can't really decide. But how many people could come in first? 8. Right? Even though you probably say, oh, that person would never win that race. It's possible lightning hits all 7 other people and they win. Right? It could happen. Okay? How many people can come in second? Well, the person that came in first can't also come in second. We're not going to imagine they decide to run back to the beginning, start again, and still beat everybody else and come in second. There would only be 7 choices for second, and then 6 choices for third. And we figured this out already at the beginning was 336. Now, according to the permutations formula, you have 8 people, so that's your 8 objects, and you are arranging 3 of them. So the permutations formula says you could have used 8p3. The reason we rarely use this formula is the spaces is really easy to comprehend and to do. But 8p3, according to the formula, is 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial. And if we write out what 8 factorial means, 8 times 7 times 6 times 5 times 4 times 3 times 2 1 divided by 5 factorial, which is 5 times 4. You can see this is very similar to the questions we did right at the beginning of class. And that your 5s would simplify. Your 4s would simplify. Your 3s would simplify. Your 2s would simplify. Everything would simplify except for the 8, the 7, and the 6, which is exactly the same as what we've found with our spaces. So sometimes what we see with this number in the permutation formula is always related to the fundamental counting principle, and that number is always the number of spaces. Right? We have 3 spaces. 8p3 has 3 spaces. And this is always the number you start with and go down by 1 each time. So we have 3 spaces starting with 8, 8, 7, 6. And so if you had another question like 10p2, right, you could think of it as 2 spaces. 10 times 9, you get 90 that way. If you use the formula, it's 10 factorial over 8 factorial. And if you're simplifying with factorials, yes, 10 factorial means 10 times 9 all the way down to 1. But in a question like this, you might want to get to 8 and just say, I'm just going to add the exclamation mark there to say that would keep on going. And I have an 8 factorial on the bottom, and those are identical, so I could simplify them that way, instead of writing all the way down to 1, unless you really like canceling things out. Then you could do that. All right, questions I would like you to try. Four, 6, 7, and 8.